What do you think of when you hear the word natural resource? Pause the video and jot down a definition or maybe a few examples. A resource is something that's of value. It could even be a person or a book or a reference, something that maybe provides information. When we put the word natural in front of it, we tend to think of something that comes from the earth. And you might have even put in your definition something that's economically valuable to society. What about an example? What kind of example comes to mind when you think of a natural resource? Well, many of us think of gasoline, right? We put gasoline in our car all the time. We're always checking the price. That's a natural resource that we deal with on a regular basis. Here are some other examples: water, coal, aluminum, forests, and gold. This is the front of chapter 16 of one of your online textbooks. There's a nice description here at the beginning of this chapter that talks about how one of the important jobs of earth scientists, in particular mining geologists, is to locate where natural resources are and how to extract them. You might have heard of things in human history known as the Stone Age or the Bronze Age, and these are actually times when human awareness of minerals occurred and people started to use things that were right below their feet. So the Stone Age began really as soon as humans appeared on the scene in the fossil record, and this is when humans used the stones or the rocks under their feet to make tools and weapons. The Bronze Age, which is shown right here, is when they started to use metals, and in fact they smelted them, which is to say they melted the metals and they combined them to make new metals. For example, they took copper and tin and they combined them to make bronze. Bronze is harder and more durable than copper by itself, and so it was used to make weapons and tools during this time period. During the Iron Age, something similar happened where there was an advance. They made steel and they used that for weapons and tools. Now I want to point something out very quickly here. This timeline from left to right is not linear. And what I mean by that is each segment of the timeline does not represent the same amount of time. For example, we have 2.6 million years here on the left, and then we have a break, and that's fine, so there's time missing. But then we have this segment here called the Middle Stone Age that represents about 250,000 years of time. This next segment, which is roughly the same size on the screen, only represents 40,000 years. And then this next segment, which is about the same, represents about 10,000 years. So that's non-linear. We don't have linear amounts of time between each segment. And the reason they do this is to blow up the detail that they want to show you at this most recent time period. And the only reason I'm showing you this is because we're going to have a geologic time lab. It's going to do something very similar with the geologic time scale. Now, to show you what I mean, if I showed you this same picture with a linear time scale where the scale was exactly the same everywhere, this is what it would look like. We'd have our 2.6 million years here, and then everything else would be this little pinpoint over here. You wouldn't be able to see the detail. So I just point that out because we're going to see something similar in lab this week. Okay, back to natural resources. Now there are two types of natural resources: mineral resources and energy resources. Mineral resources are usually used to make things. So for example, gold is used to make jewelry. This is a large evaporated lake with salt on it, and salt is used for food and also for de-icing airplanes and roads. This is a quarry of rock, not technically a mineral, but a rock. These are big slabs of marble that have been cut and are ready for use, probably in construction. Energy resources, as it sounds, are used for energy. They're either used to provide heat or to generate electricity. Here's an oil rig that is pumping oil out of the ground. And here is something that you might not be familiar with. This is a geothermal facility. And what you're seeing here is steam coming out of the earth naturally. This is a particular region where the earth is very hot near the surface and the groundwater is being heated up and producing steam. So what we have here is geo, which means earth, and thermal, which means heat. So this facility is creating electricity using the heat of the earth. Now there are two categories of resources that are very important: renewable resources, which are resources that are very abundant or can be replaced on human timescales, or non-renewable resources, which cannot be replaced on human timescales, but are formed by geologic processes that take millions and millions of years. Fossil fuels fall under this category of non-renewable resources. So what is a fossil fuel? Well, a fossil fuel is an energy resource, and so I just talked about energy resources, and they're typically derived from organic materials preserved in the geologic record. So what's an organic material? Well, it's carbon-based. It was once living. Now, there's a pretty common misconception that fossil fuels were derived from dead dinosaur bones. That's not true. Examples of fossil fuels include oil, coal, and natural gas. So again, all of these are fossil fuels, and they are non-renewable resources. When they're gone, they're gone. Let's take a look at these same pictures we looked at before and put the slides on pause and decide if you think these are renewable or non-renewable resources. So it turns out that the geothermal facility is renewable. We have lots of heat inside the Earth. The Earth is not going to be cooled off anytime soon, so that is a renewable resource. The rest of these are non-renewable resources. When they're gone, they're gone. And in fact, the fossil fuels that were represented down here by the oil are going to be gone pretty soon. And in fact, lots of people suggest that we live in the oil age. Now, I just showed you a timeline of the Bronze Age and the Stone Age. Here we are in the oil age. So here we are actually today, 2020. This is 1820. This is 2220. And here we are at the prime of the oil age. So in a couple hundred years, many people predict that the world is going to be a very different place with no oil. We won't be here to see it, but it looks like it's going to happen. So back to our two types of resources. Here's some other examples. Pause the video and think about whether these are renewable or non-renewable resources. All right, here are the answers. Water and forests, those are renewable resources. Coal, aluminum, and gold, non-renewable. Here are some additional examples. What do you think about these? Wind and sunlight, renewable. Copper, soil, and diamonds, non-renewable. You might think soil could be renewable, but soil takes thousands of years to form naturally, and we're using it at a much faster rate than that. I want you to think about something that you use today and try to figure out, is it made of renewable or non-renewable resources? When I do this in class, these are some of the things that students think about. What are they made of? They might be made of metallic minerals, non-metallic minerals. They might be made of plant-based materials like wood or rubber. How many of you thought of something made of plastic? Where does plastic come from? I want you to do me a favor and take a pause on this video. And in Canvas, you'll see that there's a 6-minute video called Plastics 101 from National Geographic. I'd like you to watch that video, and while you're watching it, I want you to think about these 3 questions. See you in 6 minutes. Okay, welcome back. Our last topic is to think about the world population growing while we're using all these resources. What's going to happen? I want you to draw this little sketch with me. Draw 2 lines with arrows at the ends, as I've shown here. And we're going to work first on the y-axis. I'd like you to put a line here and here, and we're going to take this region here and we're going to divide it into 8 parts. So first, divide it into 2 parts with a little hatch mark, and you can do this approximately, although I would use a ruler to draw these nice straight lines. Then you have 2 segments. Divide each of those in half, and then divide each of those in half. And now you've got 8 segments that you can label 0 through 8. That's going to be billions of people. On the bottom, we're going to do something similar. We're going to start with a line, and then we're going to divide this region in half, and then half again. And that's it. This is going to be time. We're going to put from 0 AD to 2000 AD. And then we're going to add some lines for the 1 billion and the 7 billion mark so that our eyes can find it when we put the points on. Now, we understand that around 0 AD, we believe the population was about 1/3 of a billion, or 300 million. So you can put a data point there. I put a star. 1804 is when we believe the world population finally reached 1 billion. This part's grim. We reached 7 billion in 2011. So now you want to try to sketch a line to connect these points. And where it goes is a good question. We do have a projection that by 2023, we will be at 8 billion people, which is not too far away. What's next? Well, there are a couple possibilities, and they're shown here. Notice that here, we are all the way up to 35 billion, and before, our previous graph was really just looking at this. What makes these different possibilities? Well, primarily fertility rate. If women keep having a lot more babies than 2 per family, then population is going to go very high. Low fertility rates will bring us down here. Coming up next, what is science?